Okay, so this week is specifically over geometric sequences. First, let's define what a geometric sequence is. Okay, so it's a sequence where each term after the first is found by multiplying the previous term by the common ratio. All right, in common ratio, that is what is being multiplied by each term in the sequence in order to find that next term. If you're given a few, oops, that's kind of smearing. If you're given a few terms to start out the sequence and they're asking you to find the next term, you're going to want to find that common ratio by using division. And that will give you whether that constant is a fraction, whether it's positive or negative. That'll give you the exact number that you need to continue to multiply by each term to get that next term. So, for example, if you had this sequence 1, 3, 9, 27, and it continues, we want to find our common ratio, which we will use R to represent that. And we're going to go ahead and work on finding that next term. Okay, so we can see that this is increasing, so we are multiplying by a whole number, likely. To find that common ratio, we would undo what we've done. So we can see that 3 divided by 1 is 3. We can also see that 9 divided by 3 is also 3. And 27 divided by 9 is 3. So we are multiplying by 3 on each one of these, so our common ratio is the number 3. And to find our next term, we would just take 27 times 3, and that would give us 81. Another example for that, we have 40, 20, 10, and it continues. Our common ratio is what we're finding, and we also need to know what is our next term. Okay, so to find our common ratio, let's look at the pattern here. 20 divided by 40 is 1/2, so 40 times 1/2 is 20, and 20 times 1/2 is 10, and so 10 times 1/2 is going to give us 5. So our common ratio is 1/2. Our next term is the value 5. One more example to go along with this. We have 3, 6, 12, 24. We need to find our common ratio and our next term. So right here we are multiplying by 2. So times 2. 3 times 2 is 6. 6 times 2 is 12. 12 times 2 is 24. 24 times 2 is 48. So common ratio of 2, our next term would be 48. And if we wanted to find the next few terms after that, we would just continue to multiply by 2 on each one. Okay, so multiplying by 2 each time is our is recursively finding it. To use an explicit formula, so to find any term, like an nth term, so start anywhere in the to find any place in the sequence, we would use this formula, and is a sub n equals the first term times our common ratio to the nth power minus 1. And so what each piece of this is, so whatever term we're looking for, the nth term in the sequence, a sub 1 is our first number in the sequence, R is our common ratio, and n minus 1 is the position in the sequence that you're looking for. The n is what we're looking for. So position of the sequence, position in the sequence, sorry, we're looking for. So if we were looking for the 6th term, we would put 6 in place of n, and that would decrease by 1, so our ratio would be r to the 5th. So let's look at a few examples to go along with that piece of information. So we're going to assume that the sequence continues, and let's talk about a ball that's bouncing. So number of bounces and the height of a ball. And let's make this an input-output table. So we have the first bounce is at 3. Let's see, the second bounce is at 1.8. And our third bounce is at 1.08. Okay, so find the values for each variable in the formula. So our first term is going to be 3. Let's say we want to know what the 9th bounce height is. So then that would be our n. So n equals 9. And our common ratio can be found by taking a second term divided by that first term before it. So we have 1.8 divided by 3. I just went from here to here, which is going to be a common ratio of 0.6. So what is our formula for this? To find that nth term, we're just going to fill this out according. So we want a sub 9. Our first term was 3. Our common ratio is 0.6. And we are raising it to n, so n minus 1. This is going to be 9 minus 1. Which is going to be to the 8th power, and whenever we put this in, make sure that you're using parentheses, make sure that it's following order of operations. We want the exponent to be used first, and so a sub 9 is going to be around, so I'm going to have to round this 0.0504.